So the topic for today's webinar is Scan to BIM utilizing GeoSLAM technology. Scan to BIM is a very common application among GeoSLAM users. Our technology makes the process fast and easy by eliminating a significant amount of field capture and post-processing time, introducing automation, as well as offering software tools that help bridge the gap between working with a point cloud and third-party BIM and CAD software packages. Again, just to introduce myself once more, thank you, David, for that introduction. But the webinar today is hosted by myself. I'm Brian Rosensteel, Senior Solutions Architect of GeoSLAM, based in the Western United States out of California. Just brief background on myself, I have over a decade of experience with laser scanning, 3D modeling, BIM, CAD technology, and workflows. And before joining the GeoSLAM team, which was over a year ago now, I was an end user of GeoSLAM systems as well as other LiDAR systems, and primarily utilizing them for scan to BIM workflows for the AEC industries. All right, so here is the agenda for today's webinar. First, we're going to do a bit of an overview of GeoSLAM, talk about a brief description of the company, what we do, and the technology that we offer. And then we're going to discuss how GeoSLAM systems compare to other solutions that are out there today, regarding overall time to produce a point cloud, level of development, and level of accuracy. Then we'll dive into the scan to BIM workflow, kind of giving you an overview of GeoSLAM's total scan to BIM package and its overall capabilities. And then I'm going to jump over to kind of a quick live demo where I'm going to show some of the software and the workflow into Revit for a hotel project that I did personally. And then lastly, we'll conclude with a summary, why you should consider using GeoSLAM technology for scan to BIM, as well as some key takeaways. All right, so in this first section, I'm going to present just a brief overview of GeoSLAM so you guys can all get an idea of what it is that we do and the technology that we offer if you are not already familiar with us. So GeoSLAM is the smart way to map and understand spaces. We make it easy to capture and connect data from the world around us, from the built environment to the natural world. GeoSLAM gives people the power to connect geospatial data from some of the most difficult environments, whether you're indoors or outdoors or underground. GeoSLAM systems can capture data virtually anywhere. Core values of GeoSLAM are speed. Users can typically capture data at least 10 times faster than with similar technology like static LiDAR scanning or traditional survey techniques. Simplicity, the systems require really minimal training and are relatively easy to use, really making our technology especially well suited for entry-level users and advanced professionals alike. Business intelligence, our systems provide you with the tools that you need to map and understand the spaces or environments that you capture. And of course, automation. Our workflows and processing are intuitive, passive, and require minimal user input. I typically refer to our systems as plug-and-play technology for this reason. So just geographically, GeoSLAM was founded and headquartered in Nottingham in the UK, but we are now a global company with 10 regional offices and a network of 90 distributors, our favorite of which is, of course, Microsol resources, throughout 59 countries worldwide. No matter where you are in the world, GeoSLAM has somebody nearby who can support your mobile scanning technology needs. All right, so let's take a quick look at the ZEB family of products. These are the 3 systems that we call our core products, but we also offer a wide range of add-ons and accessories that we'll not be covering in depth in this webinar. For info on the complete suite of products, please visit geoslam.com and or reach out to Microsol resources for more info. So starting on the left, we have our ZEB Go. ZEB Go is a handheld laser scanner designed for everyone to use. The ZEB Go is really your first step in SLAM-based handheld technology. So whether it's the first time you've looked at digital surveying or you want to equip each one of your sites with the smartest SLAM, the ZEB Go is the best place to start your search. This is also worth noting that the ZEB Go comes in at the lowest price point of the ZEB family and is just as accurate as its other ZEB counterparts, but does produce a bit of a lower fidelity output. Then we have the ZebRevo RT in the middle. Scan, process, and track your progress as you go with the ZebRevo RT. It's handheld, it's lightweight, easy to use. The Revo RT allows you to rapidly build highly accurate 3D models within minutes, all while on the move. The complete solution that allows you to start mapping the world around you today with any Wi-Fi enabled device. You can scan, visualize, and process simultaneously as you walk. This system also eliminates a lot of post-processing time because your data is already a complete point cloud right off the data logger. And then last but not least, we have the Zeb Horizon. I refer to this as the big brother of the Zeb family. Very easy to use, but has an overall range of 100 meters and the highest point density with a point density of 300,000 points per second. Zeb Horizon is great for outdoor use and capturing large spaces, including spaces where features are positioned further apart. It's of course lightweight and compact design, also makes it well suited and perfect for indoor surveys as well. With its long range and high point density, the system has the most robust and forgiving SLAM available on the market today. This system also allows you to capture data in ways that others can't, because you can mount it to a vehicle, you can mount it to a UAV, you can put it on a backpack, as well as various other modes of capture. It also integrates into our Zeb Locate and Zeb Discovery systems, which we'll not be covering in today's webinar, but I encourage you to check out on our website. I personally don't believe that there's such thing as a one-size-fits-all mobile mapping solution, but the Zeb Horizon is about as close as you can get in today's market. So all these systems can be used for scan to BIM work, depending on your overall range and data density / detail requirements. So just to talk really quickly about SLAM, all of our scanners use the same SLAM algorithm. SLAM is an acronym standing for simultaneous localization and mapping. Essentially, this algorithm creates a digital map of any environment as the system and or the operator move through it by using 3D LiDAR and IMU data to rapidly create a point cloud. And GeoSLAM systems are not developmental products. They have been tried and tested across many industries. And here's a small sample of the numerous customers that are using GeoSLAM technology for their daily projects today. So GeoSLAM and our team of industry experts
Brian, I think we lost your audio. Brian, I think we may have lost your audio. Or maybe I lost audio.
No, I can hear you, David. I did lose Brian. I'm not sure if it's his Wi-Fi or something.
Yeah, we just lost Brian. His audio, not him personally.
He's still somewhere in California. Sorry about that, folks. We will try and figure out what's going on with Brian's call right now. It does say that he's offline, so I'm not sure if he was having an issue.
Oh, maybe something happened.
Yeah, I know some folks over here were asking about the pricing, and I think that was something that we would have to get back to you after the webinar.
Yeah, if you're interested in pricing, you can follow up, and we'd be happy to send you some information about that.
Yeah, and also I should probably say that we have I appreciate everybody attending today's webinar, and you will hopefully see the rest of the presentation soon. But also for everybody else, just wanted to let you know we do have an article that we did about Scan to BIM. So, at your leisure, you can read that later on. And I just posted it in the chat box, so you can have that link as well.
Building's life cycle from initial.
Oh, and he's back.
Yes.
All right. Sounds like my connection's cutting out here. You guys hear me now?
Yes, now we hear you.
Okay. Where was I? Where did I leave off?
I believe you were going over the competition, GeoSLAM versus other solutions, and then we were going to get right into the scan to BIM.
Okay.
And Brian?
Yes, go ahead.
Yeah, it's Annalisa. I was wondering if you have another issue with your audio. I was wondering if you want to call in instead. I wasn't sure how secure your Wi-Fi is.
Yeah, typically I don't have any issues, but it looked like I just cut out there for a second. I wasn't really sure what the case was.
Okay, well, wait, and then I guess if this happens again, we'll ask you to call in if that's okay.
Yeah, no problem.
All right, great, thank you.
Okay, so we're saving time, we're saving money, we're digitizing our space. You have information with the digital twin at your fingertips. This information can be used throughout the life cycle of a building, from initial construction to building maintenance, management, redesigns, tenant improvements, etc. One of the most noteworthy challenges that GeoSLAM technology helps overcome is compatibility and interoperability with other platforms. All the data from GeoSLAM software can be easily exported into numerous universal file formats, which make GeoSLAM data easy to work with in any third-party software that accepts point cloud data. GeoSLAM Draw also exports ortho images and vector data into DWG format, which can be used in most CAD and BIM software to supplement or in place of a point cloud. And then additionally, our floor plans tool for Connect will export a scaled PNG image, which can also be used in any software for those who may not have access to a point cloud enabled software. All right, so let's talk about GeoSLAM versus other solutions. So on this slide, we show a real-world comparison of overall time to create a point cloud with a traditional tripod-based static scanner versus a GeoSLAM real-time mobile scanner in a typical mid-sized commercial office space. So with a static scanner, you have to scan for a few minutes at a time from a fixed position and then move the system throughout the space, making sure that you have enough overlapping data from one position to the next. To capture this space with a static scanner, it took 125 scans at an average of 2.5 minutes each. Scan time varies, of course, depending on the system and the settings that you're using, but this is kind of a fairly average scan time for this type of space. So at this pace, it took over 5 hours of overall capture time. Then you take that data into a registration tool, which on average takes a few minutes per scan to post-process, register, QC, and export. This process and time vary depending on the system and software that you're using. But again, this number reflects an industry average. So overall, you're just looking at about 2 days, a little over 2 days of work to produce a finalized point cloud with a global accuracy of 1 centimeter and local accuracy of 2 to 3 millimeters. Again, these are industry averages. Now let's look at the same space captured with the GeoSLAM real-time system. We were able to capture this space in about 30 minutes, and that includes prep time and teardown time. The data is stitched and processed on board the data logger in real time, so post-processing, registration, QC, and export time are really minimal, and it only took about 30 minutes to produce the final point cloud in a universal file format. So for this project, the total time to capture the space with the GeoSLAM system and produce a point cloud was only about an hour, which is 18 times faster than with the static scanner. Now we do sacrifice just a little bit of accuracy, but we still have a global accuracy with GeoSLAM systems of 1 to 3 centimeters and a local accuracy of 5 to 10 millimeters, which should be sufficient for a large portion of scan to BIM work. Now let's talk a little bit about where we fit in the BIM, LOD, and LOA scales. So these standards are widely used in the BIM industry and give you kind of basic descriptions and metrics regarding overall level of development and accuracy of BIM deliverables. So I won't get into the details of these standards, but if you're not familiar with them, there are numerous resources available to help clarify. I'm also certain that the Microsol team is well versed in these standards as well. So in regard to the LOD scale, GeoSLAM systems can easily be used up to LOD 300 and possibly in some cases up to LOD 350. Past that, you'll probably want to consider using or supplementing a static LiDAR system or other survey technology into your workflow. So similarly, on the LOA scale, level of accuracy scale, GeoSLAM systems can be used up to LOA 30. This defines a local accuracy between 5 and 15 millimeters. If your work requires a local accuracy of 5 millimeters or less, again, you may want to consider using or supplementing a static LiDAR system or other survey technology. But based on my experience, somewhere between 60 and 80% of all scan to BIM work that's taking place fits within the capabilities of GeoSLAM's technology. And as we've seen today, these systems can capture data in a fraction of the time. All right, so let's talk about the scan to BIM workflow with GeoSLAM and what that looks like. So here we have kind of a high level overview chart that breaks it down into 5 basic steps. The first step is capture. This is really as simple as powering on the scanner, initializing a scan, and then you can walk freely to collect your data. When you're finished, you can quickly and easily transfer that data off the system as a .geoslam file. Then we process by dragging and dropping the data into GeoSLAM Hub, which is our processing software. And that's where it will be processed into a finished point cloud. This step is really automated and passive. So depending on the GeoSLAM system that you're using, the process to create the point cloud can take minutes or it can take up to 1 to 2 times as long as your scan time. So as an example, 15 minutes of scanning would take a maximum of 30 minutes to stitch together into a point cloud, and that's with our higher end Zeb Horizon system. Then we can quickly view the data in our 3D point cloud viewer, verify that everything has processed and stitched correctly, and then if you want, you can export straight out of Hub into a universal file format and use it directly in a third-party platform. Or you can bring your data into GeoSLAM Draw BIM and prepare your point cloud data, extract floor plans, sections, use the Revit plugin to do side-by-side feature extraction into Revit. And then from Draw, the data can be, once again, exported to universal file formats and even some proprietary formats like RCP from Autodesk or POD from Bentley Systems. You can also export 2D ortho views and extract vector line work into DWG format. So all of the tools available in Draw are designed to help extract the info that you need and prepare your data for third-party CAD and BIM software packages. That's really what Draw is designed to do. So diving a bit deeper into the process of capturing data with the GeoSLAM system. Now we've got a bunch of images here of field capture in various different sites. So whether you're working with a ZebGo, Revo RT, or Horizon, the process is pretty much the same across the board. Essentially, all you have to do is power on the system, start a scan, pick up the system, and then walk freely through the space or environment that you want to map. As you move through an environment, the SLAM algorithm does most of the heavy lifting by identifying features and surfaces and then simultaneously tracking the system and your relationship to the environment and around it, which is also reinforced by an onboard IMU, or inertial measurement unit. As a result of the SLAM algorithm, an accurate point cloud is generated. So when you're finished, you simply return the system to the point where you started the capture, and then the data is easily pulled off the data logger in a .geoslam format. That's our proprietary format. So our systems work really well in most environments with only a few limitations. When scanning, it's important to continue to, as I say, feed the SLAM with features and try to avoid featureless environments like wide open spaces or smooth, straight corridors or tunnels. However, these types of environments can typically be captured by introducing artificial features into them. Our systems also perform quite well around moving objects or reflective objects, as well as both in confined and open spaces. GeoSLAM systems also do a great job of tracking change in elevation as you go up ramps, stairs, steep grades, things like that. Overall, the capture with a GeoSLAM system is really easy and can be taught to a non-technical user in a very short time frame. So again, this is what I consider plug and play technology. Once you have the .geoslam file off of your data logger, the process to turn that raw data into a finished point cloud couldn't be easier. All you have to do is drag and drop that GeoSLAM file into GeoSLAM Hub, and the software does the rest of the work for you with our SLAM algorithm, which stitches the data together into a finished point cloud. With the Revo RT system, the SLAM is done in the field as you capture. So in Hub, you're simply converting the data and creating a project, which usually takes about a minute or less. Then in Hub, you can perform secondary processes on the data like colorization, georeferencing, adding panoramic images, merging multiple captures, reprocessing, and exporting your data to universal file formats, as we already discussed. Our Hub viewer allows you to view and QC your data in minutes in either 2D or 3D. It also allows you to create sections, view your trajectory path, and view with different colorization settings. So once you're finished processing your data, you can either export it directly to a universal file format, or you can create a draw BIM project in order to create additional outputs and work with your data further. So here are some visual examples to show you what the outputs from draw look like. And we'll see some of these in our live demo as well. But you can export two-dimensional ortho views, which are essentially flat 2D images of your data and are created from slices or sections of the point cloud. In Draw, the user has complete control of these outputs, and they are written to a DWG format, which can easily be brought into most CAD and BIM platforms to be used as an underlay to support modeling or drafting work. From these views, we can also automatically create vector line work, which is also written to DWG format. You can then use the manual vector tools in Draw to refine, clean up, and finalize your drawing, or you can bring the auto extraction into a CAD platform to be finalized there. So this tool can save a lot of time when it comes to generating 2D drawings, or these vector lines could also be used in a 3D BIM platform to be extruded into 3D elements. Also for Revit users, Draw BIM offers a plugin that allows you to do side-by-side feature extraction in order to quickly model basic elements like levels, walls, doors, windows, columns, etc. This tool can save a lot of time and add accuracy to the scan to BIM process in Revit. And here is a quick demo video of the Revit plugin in Draw BIM. So with this tool, we can quickly and easily extract model elements like levels, walls, doors, windows, etc., as well as other architectural features. Of course, we can also use the point cloud and or ortho images in Revit as an underlay, and then use the native tools in Revit to model these or other architectural, structural, or MEP elements in a similar way. So the Scan to BIM package with GeoSLAM really gives the user the tools that they need to do this work, but offers the flexibility to allow users to decide the specific workflow and methods that would be best for their work and or projects. So one important takeaway regarding overall accuracy when it comes to Scan to BIM is that the accuracy and detail of your model can largely be dependent on the abilities and attention to detail of the modeler. Also, many Scan to BIM projects are developed with design intent, which typically means that you're keeping walls straight in the X and Y axes and holding angles to 5-degree increments. So in this case, you're typically sacrificing a bit of real world and local accuracy to some degree. So having a point cloud with millimeter level accuracy actually becomes less crucial for design intent modeling and drafting. So this is why GeoSLAM technology is such a good fit for Scan to BIM work, because the overall field capture is very fast. And even though you're sacrificing a bit of accuracy in the point cloud data, the model that you're able to create with the GeoSLAM point cloud versus a point cloud from the static scanner should be fairly similar in overall accuracy and level of detail. This data set comes from a previous slide where we were comparing GeoSLAM to a static scanner. So here we can see a really quick example of what you can achieve with GeoSLAM's Draw BIM tools in Revit. So then once we're out of Draw, where can we bring the data next? As I mentioned, we can export GeoSLAM or export data from GeoSLAM software to universal file formats, as well as some proprietary formats from companies like Autodesk and Bentley. We can then take that data and easily integrate it into third-party platforms, including, but not limited to, the BIM software packages shown on this slide. GeoSLAM data can integrate with almost any software on the market that can utilize point cloud data. So automated scan to BIM feature extraction is also really becoming kind of a boom market in this industry and quickly increasing in popularity. GeoSLAM data is also able to be used in many of these software tools as well, using universal file formats. So please feel free to reach out to us and or Microsol resources if you have questions on how to utilize GeoSLAM technology for a specific third-party platform or workflow. All right, so now we're going to jump into the live demo. So give me just 1 second to pull up GeoSLAM Hub. And hopefully you all are seeing my screen. So I just wanted to give you kind of a quick overview of what this process looks like. So this project that I'm going to show you today is a mid-sized hotel. It's got about 40 suites, 45,000 square feet of total interior space, also including an exterior and garage scan. So as you can see here, I've captured this in 5 different captures. So each capture is labeled by the location recaptured. So garage, exterior, levels 1, 2, and 3. Really quickly, I'm going to go ahead and open up the viewer for the exterior and just show you what the overall results look like. Really quickly, I wanted to note the overall range of the system. You can see how high up we're able to capture on the surrounding buildings and how far away. Again, this is just the raw data that we're getting off of the system. So I have not modified or manipulated this at all. So zooming quickly into the front of the building, you can see the red line trajectory. That's actually the path that we walked when scanning this space. Also really wanted to show you that the horizon system, which is the system that I use to capture this information, also collects and displays intensity value, which helps you show variations in material properties, as we can see here. And I think those really get highlighted really well as we go into Autodesk Recap. So I'm going to jump out of this viewer and quickly also show you the first level of this building in our viewer. Let's load it up quickly. So I did a bit of exterior scanning as well while I scanned the first level. But I wanted to quickly show you a clipping box of this first floor. So I'm going to cut out everything except for the ceiling, and we can quickly zoom in. Again, we can see the trajectory path and kind of the overall detail that we're obtaining inside the space. We also can view this by floor in 2D as well. So this gives you kind of a nice overall top-down silhouetted view of the data. And again, note the red line trajectory path that we walk to capture the space. So I believe each floor in this was somewhere between 20 and 25 minutes of total capture time. So the entire space was captured, the entire building was captured in, I believe, about an hour and a half of total time. So lastly, I wanted to show you really quickly how we merge these data sets together or register them together. So with our merge tool in Hub, I'm just going to show you the garage and exterior and open up the merge tool. Essentially what this is going to show you is a visual top-down and side view of the data, and we are going to manually kind of move these into place. Now, when I scan this, I started each of my scans at the same location, so they all have the same origin point. But it's going to make it really easy to stitch the data together, but you don't necessarily have to do that. So I'm going to quickly lower the complexity and then just kind of pan and move these into the correct location, something like that. Get it close enough. We can also view this on a side view. So once I've got this roughly kind of in the correct position visually, the SLAM algorithm is actually going to do the rest of the work. So this isn't like you'll see in some registration tools where it's just doing cloud-to-cloud registration. This is actually using the SLAM algorithm to merge these multiple data sets together. And I could have done this with all 5 of them. I just didn't want to sit here and watch them load. So just wanted to show you kind of a quick view of this merge tool. And then we choose a file path that we want to send the merged files out to and hit start merge. It usually only takes about 10 minutes or so to process and stitch the data together. Then once we do that, we'll go directly into our draw software. So all I did was started a new draw project and brought all 5 of my captures in here. So you can see I've got the garage and 3 levels here in the draw BIM package. So what we're generating here by default is 3 standard views. So top to bottom, front to back, left to right. This is basically all of your data in a see-through silhouetted ortho image. And as we zoom in, you can see that you're kind of seeing through all the floors at the same time on these standard views. I also did a process to align the data really quickly using this align tool. And basically all we do is we select 2 points. The first point that we pick is our 0, 0, 0. And the second point that we pick, it's going to define the rotation of the x-axis. So it's already set up to be rotated in along the long x-axis here. We can also go into a side view and set our elevation really quickly as well. And I'm just kind of roughly showing you how this comes together. But I'm not going to process this at the moment because it's already been done. So I'm just going to select this and delete it out of here. Next, what we can do is we can create layout and section views. You can see I already have a layout here for the 2nd floor that I've actually already brought into our Revit project as well. But just to give you a quick overview of what that slice looks like. If we want to create a new one, I can go into, let's go into the front view here. And I'm just going to grab my layout and section tool. And essentially all you're doing is drawing a line through the building. We can adjust the parameters of this really quickly just by grabbing the grips. Same thing from a top view. I'll pull these in really quickly. And then to create a new view, I'll hit play. And this usually only takes about a few seconds to generate. So what's really cool about these ortho image views, and I mentioned this earlier when I was showing the presentation, is that they're writing to DWG format. So if I click on my first layout here and I go show in folder, you can see all of my DWG files that are being generated out of this tool. Just give this a couple more seconds to create. And there's my layout of my first floor. I just generated that very, very quickly. And now what we can do, a secondary process, if we want, is to extract 2D vectorized line work from this as well. So I'm just going to do a small portion of my data as opposed to the whole thing, but I'll show you an example of what that looks like to select the whole thing. So I'm just going to grab this corner here, and you can see it's kind of searching for line work in the ortho image. I'll press the play button to find lines. Again, this usually only takes about a few seconds. And now you can see we've got kind of a raw line work extraction of our overall data set. Now from here, we'd probably want to clean this up a little bit, get rid of extraneous line work on furniture in the middle of the room. We can also connect up lines that are parallel to each other really quickly by doing this type of process. We can also connect lines that be at a 90-degree angle really quickly. So just to kind of show you a quick overview of how you can clean up this data.
Brian, real quick, I don't want to interrupt, but you can also can you also change the settings of how it picks up the lines to make it more or less sensitive or anything like that?
Yes, so that was over in the job editor as I was highlighting that area. You have this histogram that you can kind of slide back and forth, and that will adjust basically the density of the lines that it's trying to pull from. So you kind of want to set that to an optimal position so that you're extracting just what you need. And then, of course, there's going to be some manual cleanup. This is kind of a semi-automated feature extraction. Also, you'll see that it missed a line here, so I can go in and manually draw in these lines as well. So it gives you kind of all the basic line drawing tools that you'll need to generate kind of a quick floor plan view. And once we're finished, I can hit the play button here. And again, this wrote to a DWG file. I can also go show in folder, right click show in folder. And here's my layout 0 DWG line work. And again, this is all going to be on the same coordinate system. It's all going to match in CAD, and I'll show you that here in just a second. So let's open our CAD project. So this is overall, I believe this is on the second floor. And I've gone in and kind of cleaned up the line work a little bit, but not too much. But hopefully you can see that as we zoom in here, we have lines that fit all of these walls. And this is just by importing the raw extraction and the raw ortho image into a CAD environment. So it gives you kind of a quick overview of how we can start working in 2D and drafting and those types of things in a tool like AutoCAD. So let's jump back to draw really quickly. The last thing I want to show you here is enabling the 4CAD tool. So I won't actually live demo this just because we kind of already covered it with that video. But right here, we can enable the 4CAD tool. And then over on the Revit side, we can enable the plugin in Revit, and that allows us to do that side-by-side modeling that we saw in that video. And then the last thing I want to show you, I'll jump back to the overall top view, is the ability to export our data. So I'm going to show you how to export all of your data at once, but you can also section it out by floor or, oh, sorry, grabbed the wrong tool, section it out by floor or by rooms or different chunks of data, however you want. But I'm just going to kind of grab the overall view. And then over here, you can see we have the ability to export directly to Autodesk RCP format or Autodesk Recap format, as well as some other proprietary formats, and including some universal file formats like 7, LAZ, LAS that are really commonly accepted pretty much everywhere. So I'm not going to run this just because it'll take a minute or two, but I am going to quickly jump over into Recap and show you what the overall results look like. Recap. So open that really quickly. All right, here we are in Recap, and I have done a little bit of cleaning just to get rid of people and things like that we're walking by, but this is more or less the raw data that comes out of the system. So as we kind of zoom in on this, you can get a feel for the overall level of detail and how we're able to capture intensity values that help you differentiate one material from the next, which is a really nice feature of the Zeb Horizon system. That is actually not available with the Revo or the ZebGo system. So just want to do kind of a quick fly through. We've got this back courtyard area with a pool. Got these patios here. So just quick fly through around this data. And I also want to show you that I have my 5 separate captures still preserved in this data set as well. So if I go into my scan locations, you can see my 5 captures right here. So I'm going to go ahead and start hiding all of my captures except for the 3rd floor and quickly edit my limit box and cut out the ceiling so that we can get a quick view of inside the building as well, just so you can see the overall level of detail. Again, I did a little bit of cleaning on this, but really not much. This is pretty much the raw data. So as we zoom in, we can see furniture and casework and things like that. There are a couple of reflections in here from mirrors and things like that that I did not clean out, but we can see a pretty good level of detail of the overall data. All right, so let's jump over into Revit, and I'm going to show you the final results of the scan to BIM process. So now I'm in Revit, looking at the overall 3D model that I've created. This is roughly an LOD 300 model, so I'll let you be the judge, but yeah, this is all derived from the data that we just looked at, kind of using the standard Revit tools, as well as the interoperability with the Draw BIM software that we saw earlier in the presentation. So just do a quick rotate around this. And also jump to another 3D view here where I've got the point cloud in. This is just the exterior point cloud. I've hidden the other ones just so it's a little bit easier to navigate around, but you can see the overall level of detail and accuracy compared to the point cloud itself. And then we'll jump into our first level, and I'll kind of fly through this so you can see what level of detail I've gone into. Of course, we've modeled basic architectural elements like walls, doors, windows, floors, ceilings, things like that, but I've also added in furniture and casework and appliances and plumbing fixtures and things like that, which are really easily identified within the point cloud, as well as stairwells, which I scanned with the system. I mentioned how well the system does in stairwells, and that's actually how we tie one floor to the next, is by creating overlapping data in the captures from one floor to the next. So I'll also quickly show you level 2, which is pretty much the same layout as level 1, minus some of the exterior stuff. But I could have very easily also drawn this level 2 by using the ortho image. So here I have a view where I've just brought in the ortho image, that DWG ortho image that comes out of the draw software, and brought it here into Revit. And again, it's all on the same coordinate system, so everything just kind of drops into place really cleanly. You can also see that the level of detail in the ortho image is similar to what you'll see in the point cloud, but it does kind of clean up some things like reflections and those sorts of things. Just gives you a little bit cleaner output. So I kind of prefer to have all of these options available to me and kind of toggle back and forth between them depending on what I'm trying to do with the data. So also just wanted to show you that we're also accurate within 3D view as well. So I've got a shortways, widthwise cross section here, and you can see all the 3 levels in the basement. This is the pool area right out here. And also wanted to quickly show the long ways section as well, so you can see the overall level of detail that we're able to obtain in 3D. So this is more or less all I wanted to show you in Revit as far as our live demo, but overall this model took about 3 days to develop, maybe 2.5, 3 days to develop from the point cloud. It includes most built elements except for MEP and possibly a few things that I missed. Admittedly, I use a combination of the feature extraction tools in Draw BIM and native Revit tools to create the model. And at the end of the day, the process to develop a model from GeoSLAM data is going to be pretty similar to modeling from any point cloud data, and the results will be comparable. The main difference is that the data in this capture only took a couple of hours to capture and put together into a finished point cloud, and the end result is very similar to what I could have achieved with the static scanner, which probably would have taken a few days to create the point cloud. So hopefully after seeing the finished result, you'll agree. But I would definitely encourage you guys to try it out for yourself on an upcoming project.